Hello, this is the last video for the Semester 2 review packet. This is the rational functions and expressions section. It looks like questions 25 through 29 in your review packet. Okay, question 25 says if y varies inversely with x and x equals 3 when y equals 4, write an equation relating x and y. So if you remember, we know an inverse relationship exists when y is equal to k, a constant, divided by x, or when you multiply x and y, you get a constant. So in A, they're asking for us to write an equation. Well, I have to know what the value of k is. To get the value of k, I'm just going to multiply x times y, so 3 times 4 is equal to 12. That's my k value. So now my equation simply is y is equal to k, which is 12, divided by x. Done. B says determine the value of y when x equals 6. So now I know x is 6, and they're asking for what y is. So take my equation, x is 6. That tells me y is 2. Okay, moving into some rational functions. It says sketch its graph and state the equation of the asymptotes. We always have two asymptotes. Remember we talked about VAX, vertical asymptote goes with x, same as excluded value, and then we have hey, which is our horizontal asymptote, and that goes with our y. So if I'm looking at this example, vertical asymptote, what makes the denominator? What makes the bottom 0? Well, that's just x is equal to 0. Horizontal asymptote, that's a little sloppy, but I look for my horizontal asymptote to see if anything's added or subtracted outside of the fraction. So here, horizontal asymptote is also y is equal to 0. So those are just kind of the normal asymptotes. They haven't been shifted left or right at all. Fall right there. And then to sketch its graph, you need to make a table. So remember that you need to pick, give me 1 second here, pick x values that are to the left and to the right of the vertical asymptote. So I can't plug in x as 0 because I can't divide by 0, but I need to pick some points to the right and to the left. It's okay to just go in order, so like you could do x is 1, 2, 3. You can kind of pick whatever works for you. I like to pick x values that work out nicely. So for example, I picked 0.5, 1, and 2. And then when I plugged each of those in, I got 4. When I plugged in 0.5, when I plugged in 1, I got 2. And when I plugged in 2, I got 1. So I have 3 points to the right of my vertical asymptote, and now I'm going to flip and do the left side. So I did negative 0.5, negative 1, and negative 2. So then I got negative 4, negative 2, and negative 1. And then I go ahead and graph those. So it's really hard for me to do on the iPad. So 0.54, 1, 2, and then 2, 1. So remember, the most important part is that you get really close to your asymptotes, but you don't actually touch your asymptotes. So then I'd be at negative 0.5, negative 4, negative 1, negative 2, and negative 2, negative 1. And if you remember, there's a kind of two parts to this graph, and they're in opposite quadrants from each other. Okay, another one for graphing. Let's do our asymptotes first. So vertical asymptote. Again, I'm asking myself what makes the denominator 0. Well, here that would have to be 2, since 2 minus 2 is 0. Horizontal asymptote is still y is equal to 0. So I'm at x is equal to 2. So there, and y is equal to 0. Then I did my table. I'm not going to go through plugging in every single x value because this would get really long, but here's where what I picked for x was 2.5, 3, and 4. Those are to the right of my asymptote, and I got 12, 6, and 3. If you want to pause this, if you didn't get the same things as me and you used the same x values, maybe check your work. And then I used 1.5, 1, and 0, and those are 3 points to the left of my vertical asymptote. And I got negative 12, negative 6, and negative 3. And then I go ahead and graph those. So 2.5, 12 is going to be off, but 3, 6, I can fit somewhere over there. There we go. And then 4, 3. So it's getting up. It'd still come down by those asymptotes. And then 1, negative 6, 0, negative 3. I know it's going to approach those asymptotes on both sides. There we go. All right, one more equation. So vertical asymptote x is equal to negative 3. Here the horizontal asymptote would actually be y is equal to negative 1. That's what's hanging, out there is that minus 1. So when I made my table, I should draw my asymptotes first. X is negative 3. Y is negative 1. Okay. X values that I picked were negative 2.5, negative 2, and negative 1. So those are 3 points to the right of my vertical asymptote. And I got 7, 3, and 1. And then I also picked negative 3.5, negative 4, and negative 5. I got negative 9, negative 5, and negative 3. And actually, nope, that's looking good. I was just checking my work here. All right, and then let's graph those. So negative 2.57, we're right up top there. Negative 2, 3. Negative 1, 1. So again, swoop it. Oops, I was way off on that one, guys. Again, make yours more accurate than mine. No, other side, negative 3.59, somewhere down there. Negative 4, negative 5. Oops, that one should have been further over because it was negative 3.5. And then negative 4, negative 5. And negative 5, negative 3. And again, it would swoop down through those points. All right, some simplifying. So here, if it just asks for simplifying, you can assume that there is no adding, subtracting, multiplying, or dividing left to do. You just need to factor the top and the bottom to see what can cancel out. So for A, the top's a trinomial. I would factor using diamond and box, which if you need a review of factoring, go back to that video. So I get x plus 2 times x plus 2. That looks good. Bottom's dots, so it'd be x plus 2 and x minus 2. Now I can see I can take 1x plus 2 from each, and I'm left with x plus 2 over x minus 2. Middle one, the top's factored already. It's just a binomial. Bottom, when I factored it, let's see here. I had x minus 4 and x plus 1. Again, worked out nicely. You can take an x plus 1. There's just a 1 on top now, and then x minus 4. That would be my final answer for B. For C, I have a monomial up top. I can't take anything out. The bottom, I can take out a 4 and a c squared, and then I'd be left with 2 minus c. From here, my 4's would cancel, take away the c squared, and then I'd be left with 1c up top. So I'm left with c over 2 minus c. I can't cancel anything else. That bottom binomial, that 2 minus c right there, remember that's stuck together, so I don't have a 2 minus c to cancel with on the top, so that is our final answer. Okay, on to some multiplying and dividing. A is multiplying, so I like to first mark off those terms that are together. So like that a minus 3 is stuck together right now, and the a squared minus 9 is. When multiplying, we're really just squishing everything together. I'm going to move this single a in front of this binomial, so I have a times a minus 3. Sorry, it's a little sloppy. On the bottom, I have 4 times a squared minus 9. Now I'm just factoring whatever I can. So up top, it's actually already factored. A times a minus 3. There's nothing left to take out. On the bottom, I can factor the a squared minus 9. A plus 3, a minus 3, getting a little sloppy, sorry. Can cancel an a minus 3. So I'm left with an a over 4 times a plus 3. Final answer. Okay, second one, I have to remember to flip and multiply by the reciprocal. So it would become m plus 2 over m plus 4. So the first one stays the same. Second one flips, so it becomes 6m and then m squared plus 6m plus 8. When I multiply it, it all really just gets squished together and becomes 1. So up top I have 6m and m plus 2. It's already factored. On the bottom I have the m plus 4 that was already by itself, and then I have to factor this trinomial now. And when I did that, I got m plus 4 and m plus 2. So now everything's factored, and I'm at the point where it's okay to start canceling. I can take away 1, m plus 2. There's nothing to cancel with my m plus 4. There's no single m's to cancel with that m up top there. So up top I still have a 6m. On the bottom I have 2 m plus 4's. If you want to write it as m plus 4 squared in the bottom, you could. That would work. Final answer for B. Alright, C, we have to take the same first step. One on the left stays the same. So y squared over y plus 2. Flip the second one. So y squared plus 2y is now on top. Y plus 2 is in the bottom. Really is all just getting squished together when we multiply. So I'm going to factor now. So I have y squared. I can take a y out of this binomial. So I'm taking out a GCF. So times y. That would be y plus 2. All over y plus 2 times y plus 2. Let's keep moving. So this y squared and y are multiplying. That would give us y cubed times y plus 2. So I'm just simplifying right now. Over y plus 2, y plus 2. Now everything's factored at combined like terms. I can take away 1 y plus 2. And I am left with y cubed over y plus 2. Okay, the last few are adding and subtracting. So first one, 3n over n plus 1 plus 3 over n plus 1. First thing we always look for is you have to have a common denominator when adding or subtracting. Luckily in this first example it is a common denominator, so I know all I'm really doing is putting the top pieces together. So I have 3n plus 3. Bottom stays n plus 1, just like it was originally in my problem. Not done yet. There's no like terms to combine up top or any distributing to do, so I can factor. Take out a 3, then I'm left with n plus 1, all over n plus 1. Those would cancel, and I'm left with 3. Doesn't always happen that way, but sometimes it does. Okay, moving on to B. Right away I look at this. I can see that my denominators do not match. So I'm reminding myself, okay, I have to have a common denominator. What is it going to be? Well, they both already share p minus 2. That's definitely coming along for the ride. I don't have to do anything with it though because they both already have it. But the p plus 1 over there has to be with also. It can't go away. So I need to multiply this by a p plus 1 also, top and bottom. So now my common denominator is p minus 2 times p plus 1. Up top I have 5p minus 2 times p plus 1. I now need to distribute that minus 2 through. So I get 5p minus 2p minus 2 over p minus 2 p plus 1. I'm going to combine like terms up top, so I'm putting these together. That gives me 3p minus 2 over p minus 2 times p plus 1. So now I factored, or excuse me, I didn't factor, I distributed and I combined like terms. Now I want to see if I can factor. The bottom's already factored, and the top, no GCF, no dots, and unfortunately there's nothing I can cancel. There's not a p minus 2 or a p plus 1 up top, so this is my final answer. Last one. Alright, so common denominator first. They don't share anything because the one on the left is a single x and the one on the right is an x plus 3. So we know the x has to come along because it's not going to go away. So I need to multiply this side by an x, so now it has an x. But the x plus 3 also has to come along. So I'm going to multiply this side. Sorry, that got a little messy, but it should be multiplied by an x plus 3 on the top and bottom. So now what I have up top is I have that 4 times that x plus 3 plus 2 times the x. Let's distribute. So I have 4x plus 12 plus 2x all over x times x plus 3. That gives me 6x plus 12 over, x, and then x plus 3. So now I distribute it, I combine like terms. I'm going to factor the top part because the bottom's already factored. Take out a 6, left with x plus 2 over x times x plus 3. Well, I can't cancel an x plus 2 with an x plus 3 because they're not exactly the same. Again, nothing canceled. That's kind of strange, 2 in a row, but that would be our final answer. All right, thanks for watching, guys. Like I've said before, and I'll say it until the very last day of school, and next year, if I see you again, please ask questions if you're stuck, or ask for more practice, or ask a friend, or look online if you need anything at all. Thanks.